This is George Sakelius, and this is Sprint 3. Okay, so this is OBB and B-Sphere, OBB and ABB. Okay, and OBB and OBB. Okay. All right. So, in my collision B-Sphere, when I compute the data, I'm storing my local min, my local max, my world, my inverse, my half diagonal center, and my scale squared. So going into actually computing the intersections, this is OBB and OBB. I'm creating a array of vectors that holds 15 vectors, one for each of the axes that I'm going to be testing. So I pass that into create 15 axes, which will then fill the vector using the these two matrices, the worlds of the OBBs, since the axes of the OBBs are just their world transformations. And then after I get those axes, I then test them for overlap, use it inside of check OBB axis collision. This is create 15 axes, is just puts in the base axes and then the cross products of them. Collision, ABB versus OBB, pretty much the same thing. Only difference is I'm sending in the identity matrix for the ABB matrix for the ABB's axes, because it's already axis aligned with the world, so its axes would be the identity matrix, would be equivalent to the identity matrix. Well, the OBB's axes correspond to its actual transform. And then same thing, check OBB axes collision. So I used my 325 notes to compute the actual interlaps. So calculate RHO. What that essentially does is it gets the projection max of the given axes and multiplies it by the scale square, and that's all it really is. So that's what it is right here. So I take my axes, I put it into local space according to the current bounding box. I then pass in my vlocal, my axes, and the diagonal for that box into projection max, which gives me my projection max right here. And then RHO is just projection max times my scale squared of that box, and then I just return that value, and that's what those are. And then calculate D, passing my axis, my centers. Where's that? It's right here. And yeah, and then I just check to see if these two values are less than D, and if they are, then one of the axes doesn't overlap, therefore there's no collision. So then I return false, and that just kicks me out of the while loop. So yeah, I think that's it for math. Then I also had to make a show OBB in the visualizer. But nothing really different than ABB. Oh, B-Sphere, I mean, it's not that different from B-Sphere and ABB. All I have to do is put the B-Sphere into local space according to the OBB, and then once I get the clamp point, take that clamp point out of local space, put it into world space, and then actually and check that new point against the radius of the B sphere. So yeah, that's pretty much all the stuff for the collision. So I also got around to drafting up a schedule. So right now I include some stuff that I already got done. So next thing on my list, I'm gonna try to basically set up the engine run method inside engine and get Kiwi to get my engine to actually derive from engine, which will essentially be my DX application. So yeah. And then below I just have I just put into writing some of my plans going forward of how to handle certain things. I was thinking about adding cell shading later down the line if I get a chance to. I just included some stuff of how I thought about doing that. And then yeah. So yeah. As for my final product, honestly, I just want something that showcases my DX app. So obviously I'm gonna include a lot more models. Gonna have a whatchamacallit, terrain model. And I'm gonna play around with lighting. As for actual game features, I'm thinking about making a couple changes to the enemy AI just to make it a little bit more tactical. Essentially, my idea was have a group of enemy tanks, but set up some kind of manager that gets them to all talk to each other and essentially coordinate an attack against the player. I've done it before in a previous class. It worked fairly well. I feel like I can replicate it for this indefinitely. So yeah, that's what I have this week.